All right, so we're going to start looking more at probability, but you need those counting principles to at least get started, because a lot of times, as we were talking before, probability is successes over total is one way of looking at it. And so we need to have those counting principles to figure out, how are we going to do this? So we've got basically one M we can work with, 4 I's, 4 S's, and 2 capital P's. They're all capital. Yeah. If the letters are randomly arranged in some kind of order, what is the probability that they'll actually arrange themselves in that order? So how many ways do you think that you can be successful then, basically, in doing that? Seeing the M has to be first, there's one way we can have this happen, correct? That it can line up like that because of where the M is. So being successful, 1. All right. How many ways can we actually jumble them up then? So what we have to find are distinguishable permutations. And so, well, how many letters are there in together? Well, we got 1, 4, 4, and 2. So what are we looking at? 11, correct? So we know we can jumble them up that many ways, right? Just jumbling up with no concern as to where things go. But again, if I start switching these 2 S's around, you're not going to be able to tell that. That's not distinguishable. Or if I switch that I with that I, you can't tell. All right? And so it's not distinguishable. And so we have to start kind of going through and saying, well, what are we going to do? How about the M's? Do we have any concern with that? No. I mean, you can put 1 factorial down there if you feel like it. That's not going to change anything, right? But the I's, we do have a problem. So there's a 4 factorial down there. And another 4 factorial for the what? S's, and then a what? Now, what are we looking for here? What is this that we're finding? Distinguishable ways I can jumble this thing up, right? Because that's going to be your total ways you can jumble it up, right? And so, yeah, go ahead and get a calculator of some kind. Those of you that are good with the calculator, you can kind of just put parentheses around that, and it works out fairly well, right? If not, you can always figure out what that bottom is first and then divide. It doesn't matter. Yes. And what? 15? Okay. Now, okay, what's this all mean then? What's the probability? We still haven't written that. We know that I can jumble up those letters in 34,650 distinguishable ways. So that's the total number of ways I can jumble it up. And how many ways can we get what we actually want? 1. So is that very probable? No. All right. Yeah, it's out there a ways. That's one that you'd probably want to leave as a fraction. Okay. Yeah, so it's not good. All right. So again, you see how we used the counting that we learned about, though. We had to know that we needed distinguishable for our successes. We needed, well, how many ways can I be successful? Well, 1. How many ways can I jumble them up that I can actually tell the difference? Well, 34,650. So we are using what we had. So determine the probability of being dealt 5 diamonds, and otherwise known as a flush. Okay, from a standard deck of playing cards. We're going to say that you only get 5 cards. Do you feel that will be very probable or not?
Yes.
Very probable of getting 5 diamonds if you're only getting 5 cards. Probable or not? Well, let's find out. So, one thing we would want to do is first find out, well, how many ways can I be successful? How many ways can I get 5 diamonds? 52 in a deck. How many of them are diamonds? 13 of them. A quarter of them, right? So first, let's find out successful. So there's 13. Does it matter? Do I have to get, say, the ace of diamonds first, then I have to get the 2 of diamonds? Because once you get it, you can rearrange them however you want in your hand, right? It doesn't matter. It's still a flush no matter what order you get them in, correct? So am I going to put a C or a P if it doesn't matter? I'm going to put a C. And how many of them would I like? Out of the 13 of them, I would like 5 of them. So do you agree that top number is going to tell me how many ways I can get 5 diamonds? That would be a success, correct? So what should go on the bottom for total then? 52 what? And why 52? Because there's 52 cards, right? And again, does it matter what order you get them in? No, I can get whatever I get. It's a hand of cards, and so 5. Okay. You want to be very careful that if you're choosing 5 on top, you're also choosing 5 on the bottom. That's probably logical. And go ahead and take a second and figure out, well, I'll give you the top if you want that number. At least I think that's what I did. 1,287. I don't know if anybody got that far. And your bottom number is considerably larger. So that's basically how many different 5-card hands you can get. Oh, yeah. The question was, can you use a calculator and test? Yes, I may make you do a couple by hand, showing me that you can do it, but I'll give you what the formula is too, so it's not that you have to memorize it or anything. Okay. And so how many different 5-card hands can you get? Yeah, a little bit bigger, yeah. That's what I got. So approximately, otherwise known as, so is it very probable to get a flush? Not really. No. Yeah. Again, we're saying a standard deck of playing cards. Shuffled. Well. 0.05%. Yeah, that's awesome. Yes, it does. I'm guessing about 0.05% of the time. Or about every, out of every 10,000 hands, it happens 5 times. It's just saying what would probably happen, not when it would happen. If they could go the next 20,000 hands without getting another one.
Or making 2 holes in less than every year.
Well, there's lots of variables, yeah. Number 3, a jury consists of 5 men and 7 women. 3 are selected at random for an interview. Calculate the probability that all 3 are men. Good or bad? Is it good probability or not so good? Yeah, probably not. So what do we have to do then? What's that tell us? Picking 3 of the 5. That tells you how many ways you can pick 3 men, correct? So is that our success or our total? That's our success, right? And some people would look at it this way, yeah, 5 choose 3 is your men, we'll call it, right? Some people would talk about the women, well, it's 7 choose, no, 0. Okay, there's where that, 0 factorial can possibly, be a problem sometimes. But we got 5 choose 3 and 7 choose 0. I'll tell you that one. 1. What's it? What'd you get? This one's actually pretty easy. It's 10. It's 5 factorial divided by 3 factorial divided by 2 factorial, so it just comes out to 3. Yeah. All right. So 10. So yeah, see, some of them are quicker by hand if you remember the formula. You can just do it quick, right? All right. So what's 10 then? That's the answer? Oh, what is it? It's the successes, correct? So now what do you got to put on the bottom then? That's kind of sometimes that gets people confused. Yes. Okay, so we have 12 people, correct? And I want to know how many ways I can do what? Choose 3 of them, right? And does it matter, again, the order? No, it doesn't matter. So your denominator is going to be, well, if there's 12 of them, how many ways can I pull 3 out of there for an interview? Not caring, if I choose this person first, then that person second, or vice versa. And we get probably a lower number than you expected. 220. And then very simply that simplifies. 1 out of 22, which is about 4.5%. It's approximately 4, or 4.5%. Well, more likely than getting a flush. Yeah, pretty much, or getting missed. So do you see how the counting principles are at work here? It's just you have to figure out when to use what. If there are no questions.